Hi, this is a demonstration of the staRt application for visual-acoustic biofeedback. staRt is a tool intended for speech pathologists to help children with speech-sound disorder learn new speech skills. The core of staRt is a real-time linear predictive coding, or LPC spectrum, which you can see moving around as I talk. The peaks in the wave are resonant frequencies of the vocal tract, or formants, which have different characteristic locations for different speech sounds like e, ah, ooh. Currently, staRt is targeted at children who have difficulty producing the English R sound, which looks like this. Er. Children with a distorted R sound will usually produce something like this. I'll transition between those so you can see the contrast. We teach our users to focus on the third peak and try to move it over to be close to the second peak. The starfish slider represents a target for the third peak. By default, it's set to a frequency based on information about age and sex of the client that the clinician entered when creating a profile for them. That information is used to look up reference values for the third formant frequency for typically developing children of that age and sex. However, the slider can also be adjusted to make practice easier or harder. The app has an interactive tutorial that orients the learner to the LPC wave and also provides examples of how correct and incorrect R appear in the app. There's also a quest mode that presents words containing R in structured practice interactions. The clinician can score the productions, and the difficulty of practice will adjust adaptively, such as presenting longer words when the clinician's scores represent a high level of accuracy. One last feature supports remote treatment sessions via telepractice. When I click this toggle, it generates a private room using the Vonage Video API. The client and I can meet in this room where we'll hear each other and see a shared screen view. For the LPC wave, the speech signal is analyzed on the client's local device and transmitted via WebSocket technology, which redraws the spectrum on the clinician's screen with no loss of frequency resolution and minimal lag. Lastly, we're working to expand staRt to other audiences. For instance, we're piloting the use of a discrete Fourier transform for sounds with primarily aperiodic energy, such as s and sh. We also are actively working to improve how the software tracks the resonant frequencies of speech, and we look forward to receiving input on that from the inner speech community.